So to go about building the system, we'll start off with the basic core of the actual robot. So what I'm doing is just going to get a cylinder, and let's give it an actual height of 0.87. So we're creating kind of a low disk to actually be the source for the motor for the actual robot. So what we want to do is just rotate this guy at 90 degrees on the x-axis, so it's standing up like that. And this is the source of the motor. We're going to make the destination object that's actually rotating by duplicating it and just translating it over slightly. Now, what I usually do is I'll build all my objects from my actual rigid body rig, and then afterwards apply the rigid body property and the constraint. So everything's positioned in its initial state first of all, and then the actual rigid body properties are applied. It just makes it a little easier to manage your scene and do things kind of in an orderly way. But for the sake of this example, I'll just go about and show you what each component's doing, so you have a good idea of how the actual mechanism of the rigid body works. So right off the bat, let's select both those guys, and let's create active rigid body objects. Since for motors, both objects need to be active rigid bodies. What we want is this inner object not to spin, so later on we'll constrain that to another object so it's fixed and the outer object just spins. So now we made them both active. What I want to do is glue them together with a hinge constraint. So apply hinge constraint. Let's just select that. What we want to do is just rotate that 90 degrees so it's facing the proper direction, and once we've done that, we'll set the initial state. Now we can go on to the actual hinge and turn that on the motor. We can set the velocity to 123. The actual torque, let's set to 320, and that's the maximum rotational force it can exert to overcome any kind of force. So basically, if you need more power, you'll increase the torque. So we play the timeline. You can see what we're getting is both cylinders spinning in opposite directions, which is correct. What we want to do now is start adding the leg object at an offset, so we'll end up getting this walking, stabbing type motion with the leg. So I'm just going to get a cube here, and let's just set this to 0.3. And again, I'm keeping in mind the scale of my objects as I'm building this. So you can see the cylinder has a diameter of 2 Softimage units. So if we stick with the 98.1 for gravity, that would mean that each Softimage unit would be about 10 centimeters, which is about right. So it's this large kind of toy robot size that I'm going to go for. What we want to do is scale that in Y. I'm going to make the leg about 40 centimeters long, so about 4 Softimage units. And I'm going to translate that down so it's just reaching the top of the cylinder. So what we want to do is make that guy an active rigid body object as well. And we want to glue these two guys together using another hinge constraint. Now this hinge, what we want to do is just deselect that guy, is rotate that as well 90 degrees so it's facing the right direction. And we also want to translate the hinge up so it's at the outer border of the cylinder, so we'll actually get the proper offset motion transferring to the actual leg. So once I've positioned that, let's set the initial state for that hinge, and let's just play that back. So there you can see we're getting the proper motion transferring to the leg, and because there's no constraining forces to lock the actual rig in place, we're getting kind of an offset motion there, but that's okay. We're heading in the right direction. So the next thing we want to do is add some constraints to actually lock the leg in position. So what I'm going to do is get 2 simple cubes, or actually let's just get one and we'll symmetry it. So we'll get a cube. I'm just going to scale that in Y because it doesn't need to be very thick. Scale it a bit in that size, and we're going to translate that over here. So what we're doing is going to basically create a little gap that the leg arm can fit through, and it'll just bang against those. And the tighter the gap, the more we'll just see a vertical motion. The wider the gap, the more it'll have room to swing horizontally, and the the wider the step. So what we want to do is create an optimal balance between the actual vertical motion and the horizontal motion. So it's rising up enough that it's able to lift the leg off the ground, but it's getting enough horizontal motion to actually move forward. Too much horizontal though, and it won't have enough torque to actually propel off the leg and walk forward. So it's always a balance between actually getting the motion you want and applying the right amount of forces to keep your rig stable. So once we have that there, what I want to do is duplicate symmetry that on the YZ plane, which is the default. So we'll put another one on that side. And these two guys as well are going to be active rigid body objects. Now what I want to do is constrain those, constrain them to the centerpiece. So we'll go rigid constraint, I'll go multi-constraint fixed. So this kind of locks it in position to the other object. Actually, what I wanted to do was not that, so I'll just right mouse click, redo the constraint. There we go. So we've got our two constraints there. Actually, we can delete this guy. So we've got something like that. And I can play that back. So you can see the leg is now staying within the actual the armature, but we're still getting this kind of offset motion because the entire rig isn't constrained to anything. So we'll do that next. So